Well, hello and good morning. Hey, thanks for joining me here on day 2 of making the simplest circuit possible and my struggles with it. Holy smokes. So I put together a little power supply here, and my expectation was I'd get some fairly nicely filtered output out of it. 90 volts, something in that range is what I'm shooting for. I ended my little project yesterday with what looked like a virtually unfiltered output you could see on the scope here. So it really left me scratching my head as to just how do I have these great big fat capacitors in here and yet I end up with something that looked like there's virtually no filtering going on. And what I kind of realized, and I'm gonna, this is all experimental for me, but what I kind of realized is probably putting in this load resistor the way I did it is not quite the way to do it here. So I think I was thinking quite clearly about it, and then when I went to do it, I kind of lost my head and did something different. So this is what I've got right now. That's what's on the circuit board over here. Diode, current limiting resistor here to avoid too much current charging this capacitor. Then I have another filter capacitor. These are 50 microfarads. These are big ones, relatively speaking. These two guys. And then what I tried to do was create a voltage divider here to split the output voltage from around 169 volts DC to my desired 90 volts. And I think the mistake I made is I'm kind of using these three as a voltage divider. This one's so small we can just ignore them. So I'm really using these two to kind of split the voltage, and I think that's a mistake in doing that. I think what I really need to do is put two resistors here in series, so it would look more like this. One resistor, another resistor, and then this would be the output here. So we're starting at 170 volts. We want to get to 90. That's roughly half. So we could put two similarly sized resistors in here. And I don't think this one's needed at that point. The other thing too is I have just too much current flowing through this thing. The resistors were all getting too hot. It's way too much. So I think if I increase these quite a bit, I might be in a good state. So let's say I put two 5K resistors in here. And after I do that, we'll take a look at the scope on this. We'll see what we get. Ultimately, I've got to figure out what happens when you hook up the radio, which is sitting right here, patiently waiting. It's going to draw more current out here, basically. It's going to cause a bigger voltage drop here. If the current draw from the radio is significant relative to the current coming down through here, then I'm going to have all kinds of regulation problems. And I guess this guy really got to go. So I'm going to set that up on my little project board here and see what happens. Okay, it's only been a couple of seconds since I stopped the video, so I went over here to start working on putting the resistors in. The first thing I discovered is this capacitor was knocked up like this and the wire connection was out, I'm pretty sure, which would explain an awful lot. Would explain an awful lot. So maybe I should test this again without making any changes now that this capacitor is actually sunk in properly. Boy, I thought these boards were supposed to be convenient, but so far it's just been tripping me up left and right. So I think everything is ready to go. I just walked out of here yesterday, did nothing, and I just walked in this morning. So we should be okay. I guess I better handle that. Scope's connected. Okay, let's turn her on. 169 here. Can you see that on the... Yeah, you can see it. Okay, so it's exactly the same result. Exactly the same result. Still doesn't make sense to me why it would look like that. How can it possibly look like that? let me take a voltage reading right on the leads of these capacitors, just to double check that they are actually engaged in the circuit here. You know, with a wave shaped like that, these meters are no longer properly calibrated, so whatever they say is not necessarily exactly correct. Hey. We might get a 0 there at times. Okay, I see why. Because sometimes this is not actually making contact, it's touching the rubber sleeve on the clip lead there. There we go. It's all connected. Still get that. So the other possibility is I'm just drawing so much current through this thing, really drawing a lot of current through it relative to what it's capable of doing. And you know, most of the time when I've been working with power supplies, it's got not just a single diode, it's got a bridge in here, which it's a little easier to rectify or to filter out the bridge output. But wow, that should be substantial. So I'm going to go ahead with my plan here. I'll get the two 5K resistors, stick them in there. We'll see what happens. Okay, so I've got the two stuck in there. I'm going to leave the scope connected where it is. We'll move it afterwards. So now, instead of there being roughly 5K in here, there's now 10K. So all told, there's about 12,000 ohms of resistance through here. If I get these resistors too big, then when I hook the radio up, it's going to be such a difference to the circuit, the output voltage is going to go a little wonky here. Okay, we're ready. Here we go. Look at the scope there. Hey, that's a little better. That's a lot better. Okay, let's take a look right on this output area here. Output, where I propose to have the output to the radio. Oh, it's even smoother. Success. So I think my thinking was right. I was kind of using this lower resistance resistor to split the output voltage against the pi filter resistors. A dumb move. That's a dumb move. It's much better to do this kind of thing. Wow, dramatic difference. Okay, what is the voltage there? Is it by any chance what we need? $67. 67, where'd you go? I'm watching this meter too at the same time. Jumping around a bit. Oh, I have a mistake. There we go. Let's hook those resistors together for real. They had, it's just the leads were touching. I actually put them in the wrong slots here. The only reason it worked for a moment there was the leads were touching. Okay, now we're back to it. Switch her back on. Hook up the scope. Oh. Okay, okay. Frankly, that's a little more what I expected. That's a little more what I expected. I was thinking just by changing these resistors, I can't knock the hum out entirely. That'd be a lucky break. So again, because I'm drawing current through this, I'm sort of overloading my little amplifier here. Now, how much current am I drawing through there? Well, it's easy to calculate, even roughly. So I'll get my. Let's see here. We've got 60. Okay, so we got, for fast calculation, we've got 5K resistor with 50 volts across it. So it's the same as a 500 resistor with 1 volt, 1/500th of an amp or 2 milliamps flowing through here. That's next to nothing. Oh my gosh, that's bad news. That's really true? There really is 2 milliamps flowing here? That's bad news, because I think the radio is going to take 3 or 4 or 5. So maybe this guy's too big. Anybody getting hot here? Better watch over these ones. It's still drawing a fair bit of current. Boy, I'm not sure where to go next. We can double these up again, put a couple 10K in here, keep building those up until this thing becomes smooth. You know, another approach here is this was actually, I got an email suggesting this, and it certainly went through my head, but I discarded it very quickly. Is to hook up the radio, put a variable resistor here in series, so the power supply is delivering its voltage to the radio through a variable resistor. Set the resistor way high, so you know for sure there's less than 90 volts reaching the radio. Turn everything on. Turn down the resistance of the variable resistor. Watch the voltage rise when it gets to 90. Stop everything. Read the value of the variable resistor. Put in a fixed resistor, and you're done. The problem with that is if the current draw in the radio varies, then the voltage drop here will vary. And what would make the current flow vary in the radio is turning the volume up. Now, to what degree? You know, is it like 10 milliamps into the radio becomes 11, or is it 10 milliamps into the radio becomes 30? I don't know. But that would result in a loss of regulation out of here, which is why I'm trying the voltage divider technique. The idea here is I should have something like 10 times the current that's going to go in the radio flowing down through these resistors. And that makes this circuit a little more tolerant to feeding out a few milliamps without its voltage going totally wonky. It's going to change, but it won't change that much. Certainly with that hum there, no hope of feeding this into the radio yet. I wouldn't even bother trying. I could put much larger capacitors in here, but that sounds like I need something so big. You know, some big whopper like that or something. I don't know. That's way too big. Even this is already more parts than I expected to be required to pull this off. Okay, I'm going to stop the video and ponder and think here for a little bit. Okay, so here's where I'm at now. I'm starting to rethink this whole thing. Is this even a wise thing to attempt? It's become more complicated than I expected. I can't be hooking up a fragile radio to a haphazard circuit. Taking this and turning it into something that can be contained either inside the radio or even outside the radio is a little tricky because things are getting hot here. I did a little calculation just to see where I'm at. Here, let me look. Let me put this on the other camera here. You can see a little better what I'm up to. Sometimes when I go over these things I realize my mistakes too. So just did a real simple calculation here. This is all Electronics 101. In fact, this is Electronics 100. It's not even 101 yet. So we got voltage divided by resistance to get how much current's flowing down through here. 10K divided by about 160 volts at this point. 16 milliamps. A little more than I expected when I put this together without calculating it out. 16 milliamps to work out the power in one of these resistors. Oh, maybe it's across the two of them. Yeah, it's across the two of these resistors. 160 volts and 16 milliamps passing through it. 2.5 watts. Each one of these is dissipating half this. A little over a watt in each of these resistors. This guy's, I don't know what he's doing, something similar. The heat in here, you know, if I take the circuit that I put together and do something like shove it inside a large shrink tube and shrink it all down, or try to pack it together, I'm going to have heat dissipation problems. it's just not looking good at this point. It's not looking good at all when the alternative is batteries. So let's just take a look at the alternative here. See what I can do. Okay, so my original intention was to do the 10 9-volt battery thing. Let me turn this off here before I get myself in trouble. There's the batteries. I have them. And all the way from China, I have multiple 9-volt battery holders. So, you know, I am ready to do the battery thing. Somehow I got it in my head that doing this might just be a little bit better. My original intention was to hide these, before the radio was in front of me, my intention was to hide these batteries away inside the cabinet, and as I pointed out before, there's just no space in this little cabinet. There's no way to do it. But the radio does have long lead wires coming out, which are supposed to go to a battery box. Here they are here. Okay, so why can't I just make my own battery box outside the radio? I mean, it's a little awkward, but it's not terrible. These wires are in very good shape, actually. They're very flexible. Why not use them somehow? So I think I'm back to building a box, sticking a bunch of batteries into it. The thing that attracts me to that is virtually nothing can go wrong. I am going to get 90 volts out of 10 9-volt batteries. In fact, I'll probably get 95 volts. Maybe I only need 9 9-volt batteries. So I think they're actually 9.6 volts. And in the end, 90 volts, 80 volts, 100 volts, doesn't make much difference in the radio at all. I think that's the route I got to take at this point. I think I'm going to abandon my little circuit here. I'll have to just take it on the chin that this didn't work out at all. And I'm sure to get this thing sorted out and working well, I obviously have some holes in my knowledge. Even though I think this is so simple. It's downright embarrassing. But, gee, I don't embarrass easy, in case nobody's noticed. I'm quite happy with my fallibility as a human being. I haven't fooled myself into thinking that I'm somehow superhuman. It would take a lot of fooling for that to happen. So, okay, now I gotta, you know, I need a box roughly like this, but not a cardboard box. I need a box about that size. Build this whole thing in. Oh well, okay. Let's see what I can do here. Okay, so I made some more radical changes here. I now have 10 I think, 10 9-volt batteries, all connected in series. The output appears down here. I have this meter up here reading the output, and you can see it's 0. So troubleshooting time once again. Holy smokes! I can't even connect batteries in series, it seems. Well, okay, so I've got a clip lead on my other meter here. We're just going to start working our way through the batteries and look for something weird going on. So we'll start here, watching this meter. 0. Okay, 9.4. 9.4. Another 9 on top is 18. 18. 28. 28. 36. It's all going fine. 36. 47, 47, 56, 56. Ooh. Oh, what's going on over here? I really don't expect putting this lead on is going to affect this meter. I think what's happening is I'm connecting both meters in series here by accident, sort of. Okay, so the problem is in here. What is the problem in there? I mean, how much problem can you have in something like this? Maybe a bad lead or something. should watch. Oh, did you see that jump to 81 there? So yeah, there's definitely, yeah, there we are, 94. So there's something going on with this. These wires have very short bared off leads, and it could well be that it's just not seated well in my little board. There we are. Now we got 94. That's exactly what I'm after. So what I plan to do now is connect this guy to the radio and run the radio. That means I got to do also the 1.5 volt cell. Geez, I don't have a battery. I don't have a battery clip for that. Whoops. Let's see what I can do here. Okay, there we are. Just temporary, just enough to get by to do a test. One of the things I need to find out for sure is the current draw on these batteries. So I'm going to use one of these meters to measure that. Not so worried about this one here. Next challenge will be to hook it up to the wires over here. Okay, the filament battery or the heater battery is not hard. It's getting the high voltage onto here properly. You know, it's a pretty reasonable assumption that the red wire is the positive one and the black wire is the negative. And this orange one you see here, you see that? Just barely on camera. The orange one just runs between two batteries. This thing's actually built for two 45 volt batteries to get the 90 volts. So it's just a matter of clip leading a bunch of stuff here, and this radio should come on. Oh, I gotta hook up the speaker. I gotta do all kinds of stuff here. Okay, I think I'm ready now. So what I've got, I'm doing this for my own sake too. I've got the 1.5 volt battery ready to be connected if I clip this to there. So the heater battery's not connected. I've got my 95 volt supply sitting here. If I want to connect it to the radio, all I got to do is take this voltmeter lead and touch it like so. This meter will start reading current. It's on a 200 milliamp scale, so I think if it read 200, it would mean 200 milliamps on there. So I think. Okay, first thing I'm going to do is with the radio switch off, I'm going to connect the 90 volts, see if any current flows. Shouldn't be any current flow. Let's try that. Okay, so you see nothing happening. I'm going to turn the radio on. This should allow the 90 volts now to find its way through the radio, but I don't have the heaters on the tubes on. So it's an interesting check to see if there's any current drain with the heaters off, and hopefully I'll see something here. Here we go. I heard a little pop out of the speaker when I did that. So there's the current drain, roughly 1.5 milliamps. I guess a little bit of research, you could find out how long these batteries will last. So if you left the radio on without the heaters going, you'd slowly drain out these batteries. It'd take a long time, I think, a very long time. Okay, next step is hook up the heaters and watch what happens with the current flow. And I can't build up the heater voltage. It's going to be all there or nothing there when I go to do this. And if I only had one more clip lead, I'd be a real happy camper. Somebody find me a clip lead in here. Okay, I've got to hunt down one more clip lead or something here. Well, nary a clip lead to be found in my house at this point, so I've just kind of doubled it up on a clip here. So I turn the radio on, we should see that small current drain. There we go. Bit of a rush in there, wasn't there? Turn it off. I think maybe I should have it switched on. I'll connect up the heater battery, and we'll watch that current, and probably won't hear anything out of the radio. I've got a antenna connected over here, and I have the speaker connected too. I didn't mention that, but it's all connected up. And I heard a little pop come out of the speaker, so I know something's making it to the speaker. Okay, with the radio off, and the B+ is connected. Okay, we'll turn the radio on. And we'll now attach the heater. And do I know for sure this is going to put current into the heaters? Well, it'll be obvious by the change in the reading on those meters. So, here we go. Oop. I heard something come out of the radio. I'm not counting on hearing anything just now. Little bits of noise. Anything bad happening here? I don't think so. 10 milliamps sounds good to me. There we are. I don't know what band I'm on. I'm sure I've got loose wires. Especially this thing seems to make a terrible amount of noise. Let's try the black one here. I think this is one of my trouble clip leads. Wow, that's a little loud. That's better. Alright, that's full volume. Like I said, I don't even know what band I'm on here. Well, there's no question it's working. Okay, so that convinces me that this is an approach that's going to work. I was kind of convinced at the start anyway. I can't see how this wouldn't work. 10 milliamps, maybe I can figure out how long these batteries will last. It sounds to me like they'll last a long time. This radio is not going to be played every day for hours every day. It's going to be a demonstration radio. The person's going to periodically switch it on to demonstrate it or hear it work once again type thing. So how many hours of playing is this radio likely to have in the course of a year? Not very much. These batteries, this whole thing will probably be functional for years. And then when it comes time to change them, it's just a matter of popping them out of all these holders and putting in a new set anyway. This battery here, I'm going to have to find some kind of obviously a better arrangement than elastic bands and clip leads. Good though. Let's switch it off here. Excellent. Okay, I get 2 thumbs up, even though my battery eliminator got eliminated. My battery eliminator was eliminated by batteries. I think this is actually a better way to go now in the long run, because the chance of something bad happening is so low, and that's a good thing. Hey, thanks so much for watching, and I hope you got a kick out of that. I still don't know whatever happened to my my way fancy power supply, but we'll just have to leave that for the next radio. I get farm radios regularly. See you on the next video.